Hello. This video would be focusing on the um, calculation of oxidation number. The focus will be on polyatomic ions and others. This is essentially a recap of what you guys have done in semester one. Um, so I hope you still remember it, but if you have forgotten it, then this video would function as a refresher. Essentially, it's quite easy. So I've mentioned before, this would be equivalent to algebra. I guess you could say that. Okay, but these are the rules. I've taken these rules from a textbook. Now, let's go through the rules one by one, then I would work out some examples for you. The important part, okay, rule number one, the oxidation number of a free, brush, okay, a free or uncombined element is zero, which means an example, if I write a sodium, that's a free uncombined element, okay? So that's zero, and they've given here, for example, magnesium. So it would have an oxidation number of zero, and of course chlorine gas. If you're wondering why is chlorine gas zero when it is actually not an element, it's a molecule here. You have two atoms combined, because this is how it exists, or what we call as a standard state. Okay, standard. Yeah, the brush is too thick. Maybe I could change the thickness. I choose thin pen. Okay, I guess I'm okay with that. Maybe I should try pencil. Okay. Now two. So for ions consisting of single atoms, again, single atom, but it's an ion. Okay, pencil's not working out. Let's change it back to thin pen. Okay. We're looking at an example being Cl, or again sodium Na plus. The charge would be positive 1. In this case, the oxidation number would also be plus 1. All right. So there's other examples here. There's chlorine -1, there's oxygen -2, and obviously this aluminium is positive 3. Rule number 3, in most compounds, the oxidation number of hydrogen. So this is kind of set. Hydrogen is going to be positive 1. There is, of course, exceptions. Exceptions are metallic hydrides, but exceptions is not something you guys should worry about for exam. When it's exceptions, we usually do not include this for calculation. And of course, peroxide. These two are examples of exceptions. This too is fixed. Hydrogen is always going to be positive 1, and oxygen is always going to be -2. Okay, moving on. Rule number 4. Compound fluorine always has an oxidation number of -1. Now that's the same applies to all the elements in halogen, bromine, obviously chlorine as well, and iodine. The algebraic sum of all the oxidation number in a molecule must be equal to 0. Now that's really important, because I'll clean that up a little bit. Okay, everything has disappeared. Giving you an example, let me think. If I were to give you an example of, say, K2CR4, K2CR4. Now, this is obviously a molecule, polyatom. There's many atoms in here, but the overall charge is 0 because there's nothing given. Okay. Therefore, the total of all the oxidation number, the total of 2 potassium, 1 chromium, and 4 oxygen should sum up to 0. That's what this means. Unless comes the next rule, you are looking at a polyatomic ion where a particular charge has been given to the ion. An example would be sulfate, for example, sulfate. So when this is given, this simply means when I take the oxidation number of sulfur and I total with the oxidation number of 4 oxygens, that would give me -2. So I could work out some for you guys. For example, what is the, let's say, dichromate, sorry, I missed that out. CR207, actually CR04 also possible. CR2072 minus. Now the question is, what's the oxidation number in chromates? So there's 2 chromates, so 2 times Cr plus 7 oxygen, so 7 times, we follow rule number 3, which is -2. We will multiply by -2, and that should be equivalent to -2. Remember, that's rule number 5 and rule number 6 actually. With the total of all the oxidation number within a polyatomic ion must be equivalent to its charge. So 2Cr remains plus 14, -14, and that's equivalent to -2. So 2Cr will be equivalent to positive, negative, so it becomes negative, come out, that becomes positive, so that's going to be plus 12, and Cr will be equivalent to plus 6. Okay, so now this is easy. It's a matter of practice. You guys can remember the key parts of these rules. You can remember all 6 rules. It's encouraged. You could practice as many as you can until the rules become something that you could easily remember. Okay, that's it. Make sure you try the questions that's coming up next. Thank you very much. Bye-bye.